Hello everyone, welcome to Study for Knowledge Institute. I am starting the Exemplar series in which initially I will cover the MCQs of all the chapters one by one after the other, and then we'll do short question answers. Okay, and then if time permits, we'll do long answer too. Okay, of Exemplar. So let's do this. So the first chapter that we are taking is real number because this is the first chapter. Now the concepts that we have is here, you can go through it. I will discuss the question only. Okay, so now the sample question is there, but I will still discuss this sample question 1. So the question they have asked is the decimal expansion of the rational number. So this is written in p by q form. So this is rational number will terminate after how many digits, or how many after decimal place how many digits will be there. So let's see. So can we write this 33 as 2 times 2 times 5, this denominator as, we know that 2 times 5 is how much, 10, and 33 over 2 times 10, we can write this as 16.5 over 10, we can write this as 1.65. Yes, in simplified version we can write this as 1.65, because when we remove the zeros we can shift the decimal to the left, so it is 2 decimal places, we got it directly. If you don't want to do this, then you have to divide completely. It is 20 and 33, 19. Okay, let me do this here. 33 and 20. So when you will do this 1 times 20 negative, it becomes 13 decimal 0, 6 times 120 negative 105. So 100. Now it's all remainder is gone, so 1.65. So after decimal how many digits are there? 2 digits. So answer is 2 decimal place. Now this is Euclid's division lemma, which states that two positive number a and b there exists a unique integer q and r. Q is the quotient, r is the remainder. So remainder value can never go above the divisor. So b is the divisor, okay, and a is the dividend. So a is the dividend, b is divisor. So b remainder will never go above b, but remainder can be 0 if it is exactly divisible. So the answer for that case will be C. Okay, let's do this exercise 1. For some integer m, every even integer is of the form. So let's write some integers. How we can write 2, 4, 6, 8, like that. Do you see that all is multiple of 2? So can we write this as 2 times 1, 2 times 2, 2 times 3, 2 times 4. So yeah, so now integer can be anything. Some integer can be anything. It can be odd, even, it doesn't matter. So if we replace that integer with like twice of m, it will always give you, like, if we multiply that integer with 2, it will always give us like even integer. So the even integer can be written in the form of 2m. Okay, now let's do the same thing with odd integer. Okay, so if we have 3, 1, 5, 7, 9. Okay, since you are in class 10, so you must have learned about the nth term of a sequence. It will be easier for you to understand if you get it. So how we can write 1? Let's do it the easier way first. Okay, how we can write 1? We can write 1, because other than 1 we have 3, 5 and 7. So 3, 5, 7 are prime numbers. These are not multiples of any other number other than 3 and like themselves and 1. So how we can write 1? 3, 5, 7. Can we write this as 2 minus 1, 4 minus 1, 6 minus 1, 8 minus 1, right? And the way we written even number was 2m. So can we write this in terms of even number? So we can write this as 2m minus 1. Okay, so the answer will be, okay, now here plus sign is given. Answer is D. So let's see how we can do this. So if we take q value as 0, m value as 0, then it will become odd number, right? So here what they did, instead of, like here I have taken m, but it is given in the question is q, so you can take q. So whether you can take 2q minus 1, 2q plus 1, you can also take 2q plus 3. The even number, when you add with odd number or subtract with odd number, it will always give you an odd number. Okay, so odd number can be written as even number plus odd number. So this number is even plus 1 is odd number. So in this form you can write it. Okay, so now n square minus 1 is divisible by 8. So n square, it is always going to be positive because it is a square. So integer, any integer if you take is divisible by 8 if n is. So what do you think, what value that should be? Let's take some value, random value. Integer can be 2, 1. So if I take 2 square minus 1 over 8, so 3 over 8. So no, it is not divisible. So when some statement is saying that it is divisible by 8, it means that it has to be divisible. There is no other alternative. Like in some cases it will be divisible, in some cases it may not be divisible, but you have to do in such a way that it is always divisible. Okay, the number that I took for integer is 2, so natural number is also 2, so it is also not correct. Now let's take the odd integer. So that is 1, 3, 5. Let's do this. 1 square minus 1 over 8, that is 0 over 8. Yeah, it is divisible. 3 square minus 1 over 8 is 9 minus 1, 8 over 8, so it is divisible. 5 square minus 1 over 8 is 25 minus 1, that is 24 over 8, it is also divisible. Now 7 square minus 1 over 8 is like 49 minus 1, 48 over 8, it is also. So yeah, this is valid. Let's check the other one, integer, even integer. So even integer is 2, so 2 square minus 1 over 8, which is giving you 2 square is 4 minus 1 is 3 over 8. Okay, so this is not, so answer is C only. Okay, let's do the next question. So 65 and 117 HCF, you need to calculate that, then that need to be expressed in the given form, 65m minus 117. So how you can write this? So first factorize this. 65 can be written as 13 times 5 and 117 can be written as 13 times 9. So HCF of this is 13. So this value is nothing but 13. 65m minus 117 is equal to 13. If you add 117 on the both side, it becomes 65m becomes 130. So m will be 130 over 65 on both side, you got 2. Okay, value of m will be 2 in this case. Yes, let's do the next question, that is 5. So the question that we have is the largest number which divides 70, 125, leaving remainders 5 and 8 respectively is. Okay, the largest number which divides 70 and 125, leaving remainder 5 and 8. So 70 when you divide a number, okay, now when you are dividing it, you are getting in this form, x times q plus 5. When you are dividing 125 divided by the same number, you are getting like x times p plus 8. So obviously it is straightforward that this number, because we are getting some remainder which is less than this, so obviously this number can never be more than 70 or 125. So these two options are discarded now. Okay, now let's try with option A. If I divide 70 by 13, I get like 13 times 5 plus 5. Okay, let me write there. 70 and 125. 70 and 125, that needs to be divided by 13. So 5 times 65 minus 5, you are getting the remainder. When you are dividing 13, 9 times is 117, you are getting 8 as remainder. Okay, so both condition is getting satisfied when you are dividing 70 and 125 respectively by a given number. You are getting remainder in 5 and 8. So in this case you are getting remainder 5 and 8 by 13. Let's check 65 by 65 is not valid because we discarded C and D by looking at the options. Now 65, if you divide the given number by 65, so 65, 70, 1 times 65, you are getting 5 as remainder in this case. But what about the other case? When you divide 65, 1 times 65, so you are getting remainder as 60, which is not correct as per the given question. So the answer is A only. Okay, so A is correct option. A is correct option. Now let's do the question number 6. So if two positive integers A and B are written as, so there is two positive integers, that is A is given as this, B is given as this. So are the prime numbers, and x, y are the prime numbers. It is very important. So we can understand that this, they have done prime factorization of this given number. So HCF of A and B they are asking. So like A is written as x cube y square, and B is given as xy cube. So if you will expand A, it will be like x times y times y, and B can be written as x times y times y times y. So if you're doing it for objective purpose, you can simply see that what is common in them. It is HCF is highest common factor. So x times y times y. So you got x times y square. But if the same question comes in subjective one, okay, if the same question comes in subjective one, in that case what you do? You do HCF of AB as lowest power of common factor. So what are the commons in this? X and y both are common. So x and y, what are the lowest power of this? 3 and 1. Which among them is lowest? It is 1. Among 2 and 3, which one is lowest? It is 2. Okay, so it will be like x y power 2. We are getting same answer, the method is different, but ultimate like background is same. Okay, so answer we got is xy square. So answer is B. Okay, now we have question number 7 with us. Let's do this question. Here, if two positive integers p and q can be expressed as this: p is equal to ab square and q is equal to a cube b, where a and b are prime numbers. So they have done prime factorization again. They are asking for LCM of this. Okay, so p value I can write as a b square, and q value I can write as a cube b. Okay, a cube b. So if you know how to calculate this, then it is very easier for you. If you do not, try to understand the way I am doing it. So when you calculate LCM, you use like whichever terms are there, it doesn't matter whether it is common or not, you just write all the terms that is present there. Okay, so a and b is present. Now you choose the power as highest. Okay, in the lowest common factor, like we choose highest power. In HCF we choose lowest power of the common terms. Here we don't care about, here we don't have to care about the common thing, we have to care about all the factor which is present. Okay, so A is present in both, although B is present in both, so there is no other factor like which is uncommon, so we have to just write A and B. So what is the highest power of A? It is 3. What is the highest power of B? It is 2. So LCM will be A cube B square. Okay, so the answer is A cube B square. So answer is C in this case. Okay, now we have question number 8. The product of a non-zero rational number. Non-zero means they are not zero. If in case if it is 0, then the answer would have been always be 0, because multiplying any number with 0 will always give you 0. So non-zero rational number is there, so non-zero rational number is there. Okay, so P by Q form is there, and you are multiplying with an irrational number. So what do you think, what type of number you will get? You will always get an irrational number. Okay, rational or irrational number could have been the answer if they have just given the product of rational number and irrational number is what. So we can have the option rational or irrational, but they are saying we are multiplying only non-zero rational number, so we are multiplying P over Q, which is non-zero. So any number you multiply with irrational number, like obviously if you multiply two irrational number you will get rational number, but when you may get rational or irrational, depends, but when you are multiplying rational and irrational you will always get irrational number. Like if you are multiplying 2 with root 2 you will get 2 root 2, so it is irrational number. Okay, so answer in this case is A. Now question number 9 is, if you have done the LCM properly then you know what the answer will be. Okay, so the least number, question number 9, the least number that is divisible. So a number that you need to find out which is divisible by all the numbers 1 2 10 all. So let's do this question. So a number is there which is divisible by 1 also, 2 also, 3 also, 4 also, 5 also, 6 also, 7 also, 8 also, 9 also, 10 also. So and this number is getting divided which is on in the numerator. So what we need to do, when we calculate LCM, those number is divisible by all the numbers whose LCM you have calculated. So we need to calculate the LCM of these numbers. So let's calculate the LCM of 2 3 4 5 6 7 8 9 10. We don't have to write 1 is always there. Okay, when we divide by 2, 1 3 2 5 3 7 4 9 5. When you divide again by 2 it will become 1 3 1 5 3 7 2 9 5. When you divide by 3 it becomes 1 1 1 5 1 7 2 3 5. When we again divide by 5, what we got, 1 1 1 1 1 7 2 3 1. Now it is not getting further divided, so we can write LCM as 2 times 2 times 3 times 5 times 7 times 2 times 3. So it becomes 4 15 4 into 15 into 14 into 3, so it becomes 60, and this becomes 56, not 56, we got 42, my bad. Okay, we got 42, so this 0 will come at the end. 6 times 2 is 12, and 6 times 4 is 24, 2520. Let's see, do we have this option? 2520, yeah, we got the option. So this is the number which is, or like the way I solved, I showed you the method, but when you do in examination in the objective one, you just check whether this number is getting divided by 3 or not. No, it is not. Is this number divided by 3 or not? No, it is not. This number is getting divided by 10 or not? No, it is not. So the only option that left is T. So you can go for that answer in that way, okay, in the examination. Now The decimal expansion of the rational number this will terminate after. So you need to do the division of this. 14587. 14587, that you need to divide by 1250. Okay, 1250. If you divide by 1, you get 1250. Subtract 8020. Okay, so you added 2, so 1 again. 1250. Subtract 7, 3 and 8. So if you put decimal here, you get 0. So I think 8 times it will be bigger. So 7 times 707, 7 5 35, 5 3, 7 2 14, 3 17, 1 carry forward, 7 1 8 8. Okay, it becomes bigger in 7 also. So we need to do with 6. Okay, so let's do with 6. So 6 times 0 is 0, 6 times 5 is 0, 3 carry forward, 6 times 2 is 12, 12 plus 3 is 15, 15 5, 1 carry forward, 6 times 1 is 6 plus 1 7. Now we subtract here, 0, 7, 13 minus 5 is 8. Now we again have 0. Here I think we can do with 7, 7 times 0 is 7. Sorry, 7 times 0 is 0, 7 times 5 is 5, 3 carry forward, 7 times 2 14, 14 3 17, 1, no, we still cannot do, so we need to do it by 6 only. Okay, so this will be 6 also. So 7 5 0 subtraction 0 0 2 1. So this number is again not divisible, so let's do it by adding 1 more 0, so that becomes 9 times, I guess. So 9 times 0 is 0, 5, 4 carry forward, 9 times 2 is 18, 2 and 2 carry forward, 9 times 1 plus 2, 11. So we got 750. Okay, now we can see 750 coming in 6 times. So 750 6 times, it will get cancelled. So how many decimal places after, like how many digits after decimal? It is 4. So answer will be 4 decimal places. Okay, now if you want to do it by trick, then let's do this. Okay, so answer is D. Now how we can do this? Can we write 125 as like 14587 over 5 cube times 2? Because this is a prime number. When you divide by 5, and obviously any number like odd number, 27 by 5, it will give you 5.4. Even 37 by 5, if you write, you will get 7.4, like that. So you will always get a 1 decimal. So if you're doing it by 5 cube, it means that 3 decimal places you will get, and when you divide any number by 2, it gives you 1 decimal places in that case. So you can write 4 decimal places if you know the trick. If you don't, please don't try this, otherwise you may end up doing wrong. So it's better to use the conventional method. Okay, so the answer is D in this case. So we have discussed the MCQs. Now in the next videos I will discuss the MCQ of the next chapter. Okay, once I complete the all MCQs of all different chapters, then I will start doing the short answer, like the next one, short answer with reasoning. Okay, so for now, goodbye, take care.